This is the third in a series of videos on confidence intervals, and in this one we're going to focus on how to construct confidence intervals. And the key to constructing confidence intervals is that there's really two parts to every confidence interval. So any given confidence interval is simply the point estimate plus or minus what's called the margin of error. And let's think what we mean by margin of error. Well, if we were studying, let's say we were going to study the average height of professional basketball players. And what we did is we took a sample of 100 professional basketball players and calculated an X bar, a sample mean. Well, we don't really believe that we got exactly the right answer. In fact, there should be some, I guess, randomness involved, if you want to think about it, or some range of values near the point estimate that we're pretty sure is the true answer. And the margin of error talks about how unsure we are that the point estimate is exactly correct. So we would add and subtract a certain amount. So for example, if the average basketball player was 6'4", we might say that we're pretty sure that the true value of the average basketball players might be between 6'3" and 6'5". So basically we add a 1-inch margin of error there. Sometimes in more practical place we call this a safety margin of safety. Right? So if this is how we're constructing a confidence interval, then what we need to do is we need to think about what we mean by a margin of error. And the margin of error really has to do with 2 points, right? The margin of error will have what's called a critical value. And you multiply the critical value by the standard deviation of the statistic. And though this is pretty conceptual here, in the next following sections we'll actually calculate some of these, and I think it'll be more clear. But the general idea is that every confidence interval has a point estimate plus a margin of error, and the margin of error itself has two different points, what's called a critical value and a standard deviation of the statistic. Well, the critical value in the simplest cases is going to be gained from a standard normal table, just like we've been using before. In general, critical value depends on your confidence level. Right? If you want to be 90% sure, the critical value will have a certain value. If you want to be 95% sure, it will have a larger value. And if you want to be 99% sure, it'll have a larger value, sure. So this depends on the confidence level. And sometimes people talk about the degree of confidence, same thing. Now, the standard deviation of the statistic, on the other hand, will depend on two things, sigma and n. Sigma is the true or population randomness, true or population standard deviation. Let's think about that for a second. What we're saying there is that if the degree of randomness of what you're studying is very large, then this standard deviation, the statistic, will be very large, which means you will have a wider confidence interval. So that would be the case if you're trying to predict something which is very random. If, on the other hand, the true population standard deviation is small, that is, there's little randomness in the model, then the standard deviation of the statistic will be smaller, and your confidence interval will be smaller. But that's not the only thing the standard deviation of the statistic depends on. The standard deviation of the statistic also depends on how large your sample is. Remember, because our ability to construct confidence intervals simply comes from the fact that we're pulling a random sample and of a certain size. So a confidence interval depends on the point estimate plus or minus the margin of error, and the margin of error is made up of 2 points, a critical value and the standard deviation of the statistic. The critical value depends on the degree of confidence you want, and the standard deviation of the statistic depends upon 2 things, the true population standard deviation and the sample size. Now what we need to pay close attention to is what makes your confidence interval large or small. We can talk about the size of the confidence interval. Okay? Well, the easiest thing would be your confidence level. The more, and what I want you to pay attention here and be really careful here is you want to pay attention to the numbers and the model or the formulas, but also rely on your common sense here. That's going to serve you well. If you want to be 90% confident, you will want to have a fairly large confidence interval. But if you want to be 95% sure, you are going to make that confidence interval larger. Right? Let me try to guess Joe Biden's age. I think he's about 70. I'm not really sure. But let's say that I'm 90% sure he's between 68 and 72. That might be true. But what if you say 90% is not good enough? You should be 99% sure. Well, let's see. I might then say that Joe Biden is between 62 and 80. Right? I'm more sure that he's between 62 and 80 than I am that he's between 68 and 72. So my degree of confidence or my confidence level rises. So the larger the confidence level, the larger the size of the confidence interval. The way that works in the formula is this. As you change the confidence level, you change the critical value. The more confidence level you would like, then the higher the critical value. The second thing about, let's say that sigma is high. And remember, sigma is the true randomness, or the randomness present in the population. Well, let's think about that. Think about that for a second. If you were studying something which was more random, then to be confident you would have to have a wider range of estimates or a wider confidence interval. If you were studying something that wasn't very random, then you could have a smaller confidence interval. So the more randoms you have, the larger the size of the confidence interval. And the last thing that affects the size of the confidence interval is the sample size n. Let's say you were wondering who was going to win the next presidential election. And what you did is you went and asked 20 people. Selected at random. But then your neighbor did the same thing, but rather than a sample of 20 people, took a sample of 200 people. Who would be more sure? Well, the person with the bigger sample size would be more sure. Another way to say that is that the confidence interval that they would need could be smaller. So the sample size, actually, the larger the sample size, the smaller the size of the confidence interval. And this is going to be true with all the formulas that we use.